All right, you made it to the final video of this module. Good job. Here I'm going to show you how to graph some polar equations on your TI-83, and then I'll show you in Desmos. But before that, to reward you for making it this far in this video series, I have found a couple of memes that I want to show you guys. It's pretty silly. Maybe you've already seen it, but just in case you haven't. It's not an excuse anymore, boys and girls. Leave my homework at home, left my book at home. You are at home. You're not allowed to leave home. Here's one my friend sent me. I like this one. Being a streamer is not a real job. Do I look like this guy? Screen cap this and meme it to your friends. Okay, that's enough of that. Let's get rid of those guys. Hopefully you enjoyed those. Let's get down to business. Okay, we are with our TI-83. I'm on this website that I use to emulate my TI-83, and I just want to show you guys how to graph things in polar form. First thing we need to do is make sure that we are in radian mode. Okay, so if you're in degree mode, swap over to radian mode. Next thing we need to do is, while we're in mode, we need to go from function mode to polar mode. There it is. Now, when you click on y equals, where you normally go to type in your equations to graph them, now you see you don't have y equals, you have r equals. R stands for the radius, the first coordinate of a polar coordinate. So you might remember in the first video, I showed you what would happen if you just type in like r equals, I think I did r equals 3. Let's do r equals 5. Remember what that's going to be? That's going to be a circle with a radius of 5, all the points that are 5 units away from the origin. So let's graph and see our circle. Ooh, why isn't that a circle? Oh yeah, because the x and y axes are scaled differently. There's a quick fix to this. If you just have to see your perfect circle, go to zoom, and option number 5 is z square. And that will make it so that the x and y axes are scaled the same. Say, there we go. We got a nice, beautiful circle, and our equation was simple. R equals 5, which reminds me of another meme that I've been saving up. Imagine needing roots, as in square roots, to define a circle. This meme made by the Polar Coordinates gang. Hopefully you guys are now a member of the Polar Coordinates gang, and your new favorite coordinates are polar coordinates. Anyway, I thought that was silly. Okay, let's graph something else. I want to show you something else pretty cool here. How about, what if we graph 4 times the sine of, whoa, I can't use my keyboard. That's right, I have to use this to click the buttons here. 4 times the sine of 3 theta. The theta button is right here, same button you used to use for x. Let's see what happens when we graph that. We get this cool little 3-petaled flower looking thing here. I'm going to zoom in a little bit so we can see that better. Oh, can we zoom in more? There we go. Isn't that cool? All kinds of cool stuff you can do with polar equations, okay? So that's how you do it on a TI-83, but suppose you don't have a TI-83, you can still use Desmos. So I'll hop over here to Desmos. The nice thing about Desmos is you can actually change the grid to polar form. If you go to this wrench icon up here and you click, where is it? It's right there. The grid, you want to do the polar grid. Look at that. Now we have all of the common angles, pi over 6, pi over 4, pi over 3, etc. Now we have that polar grid like I showed you on my paper a few videos ago. So now, of course, if we graph r equals 5, we get that circle with a radius of 5. And if I want to, if I use a slider, r equals a, what happened there? That's interesting. Why isn't the slider working? Oh, there we go. Add slider on r. So that way I can just make my circle grow. That's interesting why it didn't use a slider for A, B, and C. I didn't know that. Anyway, so we can change the radius of our circle like that. Okay. Let's graph that other one that we had there. R equals, what was it? 4 times the sine of 3. And if I want to put in theta, I just type in theta, T-H-E-T-A. And there I have that same 3-petaled flower. And the cool thing about Desmos, as you guys know, is we can add sliders in here and see what happens. So instead of 4, I'm going to put in A, and I'll add that as a slider to see what that number there in the equation does. Oh, it looks like it just scales me up and down. If I go negative, okay, the pedals switch position. Cool. All kinds of fun we can have in here. What if I made a slider for B for 3? Turn that into B, add a slider there, see what happens. Whoa. Changes the number of pedals and their orientation. Crazy stuff. Okay, I would encourage you guys before you do the next lesson to just hop in here into Desmos and start playing around, because polar equations are really fun to mess with, especially in Desmos. So anyway, hope you guys enjoyed that. Congratulations on making it through this series. +1 respect if you made it this far. I will see you guys in the next series. Good luck on that quiz. I'll see you in Zoom. Bye.